Hello everyone, welcome to lecture 16. Lecture 16, the title is Introduction to Soil Reinforcement. So from this lecture, we're gonna talk about the soil reinforcement mechanism and the purposes and how we can interpret and analyze the effect of soil reinforcement in the soil. The learning objectives of this lecture is to describe the soil reinforcement purpose. So we can find out why we are using this soil reinforcement and how does it work, mechanisms. And we're going to review the application areas and types of soil reinforcement, and we'll characterize the differences between geotextile and geomembranes and the geogrid. Okay. So you have this handout in the lecture note. So it tells you what the definition of the soil reinforcing or soil reinforcement. So the soil reinforcing includes a tensile resistant material. This is a keyword in the soil. So we are inserting some tensile resistant material in the soil in order to improve its stability to sustain applied load and gravity induced body force. And reinforced soil refers to the soil which is strengthened by a material able to resist the tensile stresses and which interact with the soil through the friction and adhesion. So also the key word is the tensile strength or tensile stress and the friction. So then what's the meaning of reinforced earth? Actually, this is pretty much the same with the reinforced soil. So actually, these two are interchangeably people use. So you can say that reinforced soil for the reinforced earth, and you can use reinforced soil earth for the reinforced soil. But reinforced earth has a little bit of narrower meaning and refers to a composite material made of this is typo, made of flat steel reinforcing strips laid horizontally in a frictional soil to enhance its strength and ability. So this is the picture showing the reinforced earth, and here these are the strips, right? The reinforcing material. So it can be like flat steel strip. And here you have a face. These are the facing. And facing give you a kind of a flexibility. So if you compare this to the rigid material or the rigid retaining wall, flexible wall gives good seismic resistance or does good seismic performance compared to rigid retaining wall. Because this facing can move a little bit, so that it gives you some ductility. But the retaining wall, for example, the gravity retaining wall like this is very rigid. So when you have a shake, when you have an earthquake road, then this kind of a flexible wall will give you a better performance against the earthquake. So this is the reinforced retaining wall, reinforced earth retaining wall. And primary purposes of this reinforcing soil is to increase the tensile strength and compressive strength, and to increase its bearing capacity when you construct the footing or the foundation, and to reduce the sediment and to reduce lateral deformation and the others. Other can be erosion control and stress transfer. Okay. So in the next page, it tells you a little bit about the history of this reinforced earth. Historically, MSEO, which stands for Mechanically Stabilized Earth Wall, is old as civilization. For example, Babylonian, like 3,000 years ago, used reinforced soil to build a temple. And in Asia, bamboo and the straw have been used to strengthen the earth as a building material. So it's been really, it has really like old history. But written in modern ages, in 1960s, Henri Vidal in French, a French architect and engineer, is credited with developing a soil reinforcing technique to a stage where it could be economically applied to a large civil engineering structure. So in 1960s, it becomes very economically available, and people use it for the large civil engineering structures. And he named his patent technique Terra Ami, or reinforced earth. So since that, we've been using this term as a just general term to describe the technique that can reinforce and improve the soil strength. In 1970s, the reinforced earth technique gained much popularity, so that it kind of spiked up. So in 1970, the use of the technique has been spiked up, and geotextile and geogrid were also boomed up in 1970s. And for example, in 1972, the first bridge abutment in France for the reinforced earth was used, and that technique also has been implemented in the first reinforced earth structure completed in the United States along the California Highway 39. And in 1975, also it was built in Australia. So it's been only about 50 years. And when you look at the evolution of the material to reinforce the soil, in the beginning, people used steel, and because it can rust, it can be corroded. So stainless steel was used, but it was too heavy and it's expensive. So aluminum and fiberglass and nylon. Nowadays, the people use some plastic material, polyamide, polyester. And the forms of reinforcement, as you can see, as we just saw in the picture, it can be like strip type, like this, or it could be mesh, this type of woven mesh, or sheet. Recent developed material is geosynthetics or geofabric. So we're going to talk about the difference between the geotextile and geogrid and the geocomposite. The application areas of the reinforced earth is you can use it for retaining structure, bridge abutment, and seawall, dams, and industrial bulk storage facilities. So there are a variety of application area of this reinforced earth. So let me give you an example. Let's imagine that you have this kind of very poor soil and you have to build some structure on it. So here you can maybe have some foundation, or you may build some bridge abutment, or highway, so there could be any kind of structure on it. So then you have a retaining wall, and the soil has to have some strength to resist this stress or pressure. So the one way is to build a pile, deep foundation for this retaining structure. Well, pile construction is expensive and poor in seismic resistance. So the alternative is to increase the soil strength. This was the poor original soil, by reinforcing the soil using some strips. So this reinforcing material can apply the confining stress to the soil that will increase the shear strength. You can see here also has some facing. So reinforcement, basically the mechanism is to give you some confinement into the soil, and that enhances the soil strength. And when you reinforce the soil in association with the facing material like this, and it gives the flexibility to retain the retain system, unlike rigid retaining wall. So it gives you the good seismic performance against the earthquake. Then what is the advantages of the reinforced soil or reinforced earth? You can just implement the prefabricated elemental material. So this kind of a construction allows for adjustment to the difficult topography very easily, and permit the use of relatively small, unskilled, and semi-skilled labor force. It can adjust to large differential sediment because you prefabricate the material, and save the huge expenses for high wall, and the saving is reported to be as much as about 20 to 60%, and it reduces the land requirement. Then what are the reinforcing material that we have? So we've said before that we can use steel, stainless steel, aluminum, or some plastic material, right? And when you say the plastic material, there are different types of plastic material. Not the material perspective. It's how you woven or make this reinforcing material. For example, the geotextile refers to synthetic permeable fabric, which have the ability to separate and filter, reinforce, and protect or drain when used in association with soil. So the key feature is that it can drain the water because it's permeable. So it can be used as a combination to increase the strength and drainage performance of the soil. At the same time, it has to filter the fines and prevent the fines migration. So geotextile will be like woven mesh type of fabric so that the water can drain out. And geomembranes is synthetic impermeable membranes to create the reservoir liners and cut off the wall when used in association with soil. So this is basically the waterproof, so that it blocks the water seepage, and it is useful for reservoir barrier. So it can be used for the barrier, hydraulic barrier, and seepage cutoff wall, and landfill liners. For example, landfill liner is that so when you put some solid waste in here, if there's a rain going in, then the water can escape, seeped out from the landfill liner. So this kind of geomembrane can be installed to contain the wastewater, and it can be used to prevent the contamination transport. So like I said, in the landfill liners, if you use a landfill liner using geomembrane, then it will block the water seepage out, so that it remove the risk for the soil contamination. And geogrid, it refers to large mesh grid made of high-strength plastic polymers to enhance its strength and stability when used in association with soil. So it's a kind of a mesh grid, and used for reinforcing steep slope by increasing the soil strength and the stability. So if you Google this keyword and search it for it, then you find the useful pictures that gives you idea of what the geotextiles are and the geomembranes are and the geogrids are. So there are handouts that you can find. In this handout, you will see a lot of application areas of the reinforced soil. Let's just go over very quickly by looking at some figures. For example, the bridge abutment here, that this is the bridge, the upper deck, and you have a foundation on the ground to support this upper deck. And if you have a cut slope like this, then using some facing and the strips, this earth and the poor soil can be reinforced, and the strength can be improved. So this can be used as an alternative to the deep foundation. And the other is like dam, also in the dam, to increase the shear strength. The reinforcing material can be used. For example, in the face, like here, the facing, because the erosion control is difficult, and there could be some wormhole or what do you say? So erosion, the scouring can climb up. So this kind of a reinforcing material can mitigate those kind of a hazard. Because if there's a water seepage, there you have a quick condition of starting from here, then it can just climb up and it can just expand more, so that erosion just keep growing. But if you have a strips like this, then it's gonna stop the erosion at that place. So likewise, embankment and foundation, you can use some geotextile or geomembranes to reinforce the soil. Here it gives you this idea that how the geomembranes or the geofabrics can be installed. And around the stone column in the geogrid tube, you can see that here this is the stone column, then geogrid can surround the stone column, so that there's no fines going into the stone column when this stone column is used as a vertical drain. So there are lots of applications. You can take a look. In the highway, if the embankment is too steep, then instead of the rigid retaining wall, you can use this kind of a flexible wall with the facings, in association with the reinforced strips. Or in the gabion also you can use it. So there are lots of practical applications, the railway and pipe works, etc., etc. So please take a look at this handout. Then we'll have some idea that how the soil earth reinforcement is applied in the geotechnical practice. Okay, so to wrap up this lecture, we've seen the soil reinforcement purpose and mechanisms and application areas and types, and we see the geotextile is permeable synthetic fabric, and geomembrane is impermeable fabric, and geogrid is kind of a woven mesh just to hold and increase the soil strength.